Hello everyone, welcome back to White Collar. Today in this video, we are going to discuss about the mixtures in detail. Before getting into the video, subscribe the channel and share this with your friends. Without any further ado, let's get right into the video. First, we need to see two important concepts which helps to study the characteristics of various types of mixtures in detail. Out of those, first we are going to see the Tyndall effect. Tyndall effect, also called Tyndall phenomenon, is a phenomenon of scattering of a beam of light by a medium containing small suspended particles. Have you ever noticed the sun rays entering a room through the window? Like you can visibly see the rays? That's because of the Tyndall effect taking place in that room. Yes, the dust in the room is the reason behind this occurrence. Another predominant example is when you see rays of light reaching you, while you are in the woods where some large tall group of trees exist. There you can visibly see the rays, because of the scattering of light due to the dust particles in the forest. At second, we are going to see the Brownian movement. Brownian motion is the random motion of particles in a liquid or a gas. The motion is caused by fast-moving atoms or molecules that hit the particles. Brownian motion was discovered in 1827 by the botanist Robert Brown. Now, it's time to compare all the three types of mixture. For that, first we need to take some properties to analyze it in detail. The properties are particle size, transparency, Tyndall effect, and Brownian motion. The particle size of the solution is less than 1 nanometer, and the particle size of the colloid is in between 1 nanometer and 1000 nanometer, and the particle size of the suspension is usually greater than 1000 nanometer. When we talk about transparency, the solution achieves the highest transparency. The other two, colloid and suspension, would not necessarily have transparency. Even though all the particles in the suspension settle down, it is still not very clear and transparent like a true solution. Up next, the Tyndall effect takes place predominantly in the colloid. It's somewhat happening in a suspension, but it won't occur on true solution, since the particles of the true solution is much smaller to scatter the light. The Brownian movement, on the other hand, occurs on both colloid and suspension, but not in true solution. Now, can we separate the mixture? If so, then how can we separate and see what's in the mixture? The answer is, yes we can. We can absolutely separate the mixture. In fact, we are going to see what are the different separation methods to filter out the substances in the mixture. There are 8 different methods to separate a mixture. Each one is used depending upon its purpose and the nature of the materials mixed in the mixture. So, we need to take a brief look at all the most commonly used separation methods. They are crystallization, distillation, chromatography, evaporation, sublimation, sedimentation and dissolution, filtration, and centrifuge. Crystallization. Crystallization is the process of formation of solid crystals precipitating from a solution, melt or more rarely deposited directly from a gas. By doing this, the present solute dissociates into the form of crystals and the impure substance remains in the solution. This process can either be natural or artificial as well. Dry ice is one of the best examples for crystallization. Distillation. A mixture of substances with different boiling points is boiled, and liquids of different densities present in it are evaporated with respect to their respective boiling points. Those vapors are then condensed to form pure substances. This type of separation is called distillation. Fractional distillation, a one in many types of distillation, is used in oil refineries. Chromatography. By this method, solutes with different absorption capacity are separated. For instance, separation of pigments from natural and artificial dyes has been done by this method. Evaporation. The solute dissolved in the liquid solution is separated. Solid solute remains in the bottom after evaporation of the liquid. This process is called separation through evaporation. Sublimation. It is the process of separation of solutes which convert directly from solid to gas. The pure solids are obtained by rapid cooling of the solute gas form. Sedimentation and dissolution. We can use this method when there is a need to separate substances, which has different densities. In the sedimentation process, the insoluble substance of the mixture gets settled at the bottom and when its upper fluid is separated. This action is called dissolution. For example, separation of oil and water mixture is done by this method, since oil and water has different densities. Due to this, oil doesn't mix with water and forms an upper fluid, which will be separated easily. Filtration. When the dissolution of insoluble solids, by simple mixing is done through filter or sieve, it is called filtration. For instance, purification of sewage water is done by the series of filters to separate the dirt, so that the water is treated right. Centrifuge. In this method, liquid mixture is rotated at a rapid speed, in which the centrifugal force effectively mobilizes the higher density material from the center to the periphery of the vessel. One of the most commonly used examples for this method is blood test. You might have come across this whenever you go for giving blood tests. Now, at last, before winding up this session, we should know, what is the basic difference between a mixture and a compound? So, let's have a brief look at it. But, based on what we are going to compare these two, there are 8 factors, under which we can easily tell the difference between a mixture and a compound. They are by definition, by their nature, by how we are separating it, that is separation methods, the ratio of composition, by how we are representing it, that is representation, by their properties, and by their boiling points and melting points. By definition, a compound is a substance that are formed by combining 2 or more chemical elements, and a mixture is a substance created from 2 or more matter that can be separated with the help of physical methods. By its nature, a compound is always homogeneous in nature, but a mixture can either be homogeneous or heterogeneous. If we define them by their separation methods, a compound can only be separated by either chemical or electrochemical ways. But the mixture, on the other hand, can be easily separated by physical methods. If we compare them by their composition, the elements present in the compound are combined in a fixed composition, whereas the substances in the mixture has variable composition. By representation, we can easily represent and identify a compound using its chemical formula. Mixture, on the other hand, can't be represented in chemical formula. By properties, the properties of the compound are peculiar to itself, since the constituents of the compound lose their original properties, while the constituents of the mixture generally do not lose its property. So, mixture properties are generally the sum of the properties of the constituents. Compounds have fixed melting and boiling points, while mixtures have no fixed melting and boiling points. With this, we've come to the conclusion of this chapter. In the next video, we are just going to see a brief overview of the matter and all its states and types. Until then, stay tuned. Don't forget to share the video and hit the subscribe button for more. See you guys in the next one.